Okay, for the second part of the review here, we're going to look at classifying triangles, and they're just going to look at the basics. We're going to look at the basic classification. So the first one is when we classify triangles, we can classify triangles based on the type of sides they have or the type of angles they have. Then we can also do what we call a complete classification, which gives you by angles and by sides, so you'll actually use two names. So the first one is, excuse me, you have the triangle here has sides of 7, 8, and 12. When all of the sides are different, we call that a scalene triangle. Scalene is when all the sides are different, okay? For the second one, and I've already got these marked, for the second one we have sides of 7, 7, and 6, which means that these two triangles are congruent. So, these two sides are congruent, so I've got two congruent sides and a third side that's not. This is called an isosceles triangle. In the third one, we've got three sides, they're all 9. That means that the sides are all the same, and we call that equilateral. That means equal sides. Equilateral means equal sides. I know it's kind of off the page a little bit, but equal sides. So equilateral. Now, let's go down here and classify by angles. When we classify by angles, we look at the type of angles that we have. And this one's called obtuse because it has one angle that's larger than 90 degrees. This angle right here, sorry, I have kids disrupting me. Oh, what a joy. So anyway, that's obtuse. Number 5, I've got three angles that are all less than 90. Let's write this. One that's greater than 90 and less than 180. That's the obtuse. Acute is this one here. Acute, that means all are smaller than 90. So 36, 70, and 74. In this one here, you have one equal to 90. Excuse me, allergies. One equal to 90 degrees, so this is a right triangle. So we've just classified by sides and by angles. Now we're going to do the complete. Complete means we're going to name each triangle with both of its appropriate names, an angle and a side. So let's look at this one first. All of the angles are different, which means what? If I were up here and I marked all these, the angles tell me about the sides. Whatever the angles are, if all the angles are different, that means all the sides are different. If two of the angles match, that means two of the sides match. The angles and the sides are tied together. So, first of all, let's look at the angle name. I've got an 81, a 35, and a 64, okay? All are less than 90, so this is going to be acute, okay? Now, because all of the angles are different, that tells me all the sides are different, and that is a scalene. So this is an acute scalene triangle. So if I asked you what kind of triangle this is, you would tell me, oh, it's an acute scalene, okay? So let's look at this one here. We have one angle that's equal to 90 degrees. So this would be a right triangle. And we have two sides that are the same. And you know that the legs can't be the same as the hypotenuse, so this one's going to be different. So this is what we would call a right isosceles. It's a right triangle because it's got a 90-degree angle, and it's isosceles because it's got two congruent sides. So let's look at this one. Okay? This one, all the angles are equal, okay? Now, you can technically call this an equiangular. And we use the word equiangular with polygons. But when it's a triangle, you don't have to say an equiangular equilateral. If all of the angles are the same, it's an equiangular, but I'm not going to make you say that for triangles because we'll just call it an equilateral. Equilateral actually implies that all the angles are the same. That one's special. So that's how we classify triangles, by names, by angles and sides.